All right. Let's talk about dynamic styling. So what we mean by that is that we want to be able to change the look and feel of the web application, right? Based on some algorithm, right? We want to be able to compute what the application looks like based on some function that gets a compute some algorithm or based on some user actions, some events, right? Instead of just being always the same style, right? So there's different ways of doing it. One of the ways is to control the strings that we assign to classes, right? So for instance, if you had certain classes that were defined like yellow, blue, red backgrounds and whatnot, right? We could apply them to class names using those classes declared in classes.css, right? And these class names up to this point, these have been hard-coded strings, strings, right? And then all the classes that can be combined to provide the look and feel for those divs, right? Now these double quotes, instead of being, we can use alternatively, we can use an expression, right? So for instance, we can use curly brackets as opposed to a hard-coded string. Right? That means that what's inside of the curly bracket is an expression, meaning something's going to be computed on the fly, either by calling some function, or we're going to be manipulating a string, right? So for instance, here we are generating the class on the fly, by concatenating the characters WD, BG, and then blue, or combine it with whatever here. With this doesn't have to be a constant. This could be a variable, right? Maybe as a result of some function call, based on that function call, this evaluates to maybe blue or red or yellow or whatever, right? And then it can be, you know, concatenated with other characters, right, to compute whatever classes that we want to apply. Okay. Or right, the expression could be, some ternary expression that, based on some Boolean expression or some Boolean computation, right, evaluates to red or green. Alongside, notice that this curly bracket and dollar sign is an expression that then gets concatenated with other CSS in there, black and padding. So all this gets evaluated into either the string, WBG red, or concatenated with black foreground and padding, or green background with black and padding. Okay. Now, alternatively, we can also definitely we could use classes, or we can say the style attribute, right? We can manipulate the object that gets assigned to the styles attribute. Now, for here, as you know, the styles attribute is a JSON object that gets assigned to the style attribute, and that object could be the result of some function call, right, to some implementing some sophisticated algorithm, or some complicated computation that goes out to some server, blah blah blah, and the output object that gets assigned to the styles attribute, right? Or here's a trivial example where we are defining a couple of objects that reuse other objects by using a spreader, and then get combined into a final object that spreads several objects into this resulting target object. Okay, and then once we have those objects, we can assign it to the style attribute. The style equal and then some objects. Okay, or we can do it inside of the the little object that gets assigned to a style. Okay, here this one is hard coded, but these one are not. See that? These are hard coded, right? Because you have the properties and the values right there and then, right? But these are objects that were declared earlier that were spreading against each other, or maybe the result of some function computation that were assigned to some variable that when we assigned to style. Now I do remember at some point we said that using style attribute is bad practice, right? Because it kind of didn't let you override the values. It's kind of like the last it's the last one that has a say on how something should look, right? And there's no way for overriding it, from outer CSS rules. And that's true, right? For instance, this case over here, we are hard coding the values. Yeah, so this suffers from the same bad practice, right, as before. But these over here are not as bad, right? Where these variables or constants or whatnot, right? These are computed. These are the result of some algorithm, some logic that could be smart enough to decide how things should look based on some criteria that is dynamic, right? That is not hard coded. As long as you can configure somehow that algorithm, then certainly it's a good alternative. Okay, I mean it could be that based on the date and the season, you might want to change the theme to be, you want to use a Christmas theme or a Halloween theme, right, or a summer theme, right, and so these could change automatically and set these styles computed, right, and applied to the style. And so that it's not as bad as hard coding something and then you can't override it at all. Okay. All right. Let's talk about how components can be parameterized. Right. So up to this point, the only parameterization that we have been uh, um, using are our own functions that we pass arguments, we pass objects, but never we have applied it to components themselves. So we have our own function that we can call and pass parameters. But if you combine that parameterization and you apply it to components, right now you have something very powerful. Right? So if you remember, components are nothing else than just functions, right? Okay, our React components that can be used as tags are just regular functions. But up to this point, all these functions that implemented components never took an argument, right? Here's the first time, right, we have an actual argument, right, that we're passing A, B. And notice that the syntax is that we are expecting to receive an object, right, or a map with properties A and B. And we're declaring that, because we're using TypeScript, we are forced to do some type checking, right? Making sure that what you're passing me are numbers, right? And then once I have these values of A and B, right, I can just use them as local constants, local variables, right? That to compute what the output is going to be, of A, B, and then rendering that is the arithmetic addition of A plus B. Okay. Now the way we pass these arguments, right, is using the syntactic, the HTML syntax, right? That because we're using the pointy bracket syntax, the HTML syntax of calling the function. This tag syntax is basically invoking that function, right? Well, we are trying to blend in these two worlds of HTML and JavaScript, and the way you pass arguments in functions is through a parameter list. But the way you pass or configure tags in HTML is by attributes, right? And so we can blend these two ideas of a function receiving parameters like this, the parameter list, and combine it with the syntax of attributes so that you can pass function parameters to the function that matches the tag by using the syntax of attributes, right? So this one, what this does is that it builds an object, right, with properties A and B with values 3 and 4, which get passed in here as an object that gets destructed, right, into the local variables A and B, which you can then use to render. Pretty cool. Okay. Now, another way that you can pass data or to a function is through children. Now, what we mean by children is that we have been up to this point, right, using tags like this, right? Where we have an opening pointy bracket, the tag name, and then the closing characters here, your closing tag over here. See that? Never have we implemented a component that, for instance, like this, that had an opening tag, right? And you had a closing tag like that. See that? We've never implemented that. Now, in XML, right, the language XML, you can uh, configure a node, right, an XML node by either providing data through the parameters like this, yeah, or you can provide data to the inner node of the H3 node by providing data in the body, right? There's two ways that you can pass data to the node, right? Either as attributes like ID, class name, those are attributes. But then notice that div here has all these attributes, ID and class name, but then notice that it has a closing div down here. See that? So everything in between the opening div and the closing div, there's the body, right? All this is the body that is wrapped up in by the div, right? Now this body, the way we refer to it in XML is that all these are child elements of div, right? This is represented in the DOM in a hierarchy where you have a node div that has an array of children of an array of child nodes, of which H3 is the first child. Then you have all these other child, plus add would be another child, right? Would be the last child of the div, of the parent div. So div is the parent node, and these are all child node, and together these are the children of div. See that? Well, we can implement, our own components, right, that can have also children. Okay, and so we need to be able to pass in the lists of all these children to, right, and the way we do that is by using children components, right? A component that is meant to be used with an opening and closing tag, like here we're building this square tag, right? Creating our own function, and it has this simple body. This is a trivial body. It's just a number, right? This is going to be passed as a single child, in an array of children, to the square function, and the way it receives it is through this object, right? That has a property that is called children. It has to be literally called children. It has a special name, almost like a keyword, right? And what this does is it captures all the nodes or a single node. It grabs all the content in the body of the square, and then it passes us a reference to it, right? And then the data type is just a a single node, right? That has a reference to whatever the body is, right? Internally, we can then treat it however we want. Here we're obviously expecting that what you're passing us is a simple integer or number, right? That can be parsed, it can be casted into a number, and then treated, for arithmetic operations like multiplying num times num, right? And then this whole thing evaluates to span with an ID, and then the actual number. So this whole square, right? This with a 4 in between, this whole thing evaluates to a span with 16, right? With 4 times 4 is 16. Okay, make sense? Here's another example where we want to declare a brand new highlight tag, right? That we can wrap around anything. Okay, and what it'll do is it'll highlight it by changing its foreground color to be red and its background color to be yellow, right? And we can wrap it around anything we want, right? And what we'll do is that it's going to receive a reference to the body, right? And what it's going to do is just going to replace replace this whole thing with the outer one is going to be a span whose style is yellow background, foreground color red, and then whatever you passed us, in this case is this lorem ipsum, this whole thing is be red on yellow. Okay, very, very cool. So another way that components can be parameterized is through navigation. As you are navigating, as you're navigating, and you end up in a page or in a component in a page, you can read the URL. So the URL, right? Um, you can take a you can ask the browser and say, hey browser, give me a reference to that path, which is a whole bunch of path names, slash path slash path slash, like this, right? This is the path name, right? So it might be slash labs slash lab two, blah, 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 whatnot, right? So you can grab that from the browser, and this could be parameters, right? You can pass in values that maybe you want to use for highlighting things, or values. For instance, if you pass me in Canvas, for instance, Canvas uses the ID of the course is encoded in the path. We can grab that ID and maybe call a database, right? Or maybe look up some data in a JSON object and then render that particular course or that particular assignment or that particular quiz using the ID. So here, for instance, we're using it to read the path name, right? And then check to see how does it end. If it ends with labs, then we apply a class. Otherwise, right, if it doesn't, then we don't apply any class, right? And this is all inside a template string, right? That is calculating a hard-coded class plus some dynamic class here. Okay? And then this allows us to highlight the table of content based on whatever path parameters come in. Okay. You can also declare placeholders, right? Where you can that the path is going to follow a particular pattern. I mean, it's going to be lab 3, right? And then you can name these path positions. You can give them names. Okay. And so for instance, you could, your page, that it's going to fall in a particular path pattern, right? That it's going to follow, some path names are going to be some placeholders, and you can declare placeholders using square brackets as the names of the folders, right? And now A and B are not necessarily, literally the keywords A and B, but instead these are placeholders that are given names. This path position is given the name A and the position B. And so within page, you can ask the browser, hey browser, give me the path name and then pattern match it with this pattern over here, and then give me whatever those placeholders, the values, the actual values. So if the actual path is lab 3, add, and then 3 and 4, well, match these placeholders, give me the values A and B. You can retrieve them by name, right, using use params. So use params, right, can parse the path, pattern match it with the position, and then give you the values, the names, match with the names that you gave it A and B, right? And then internally, right, these are strings that can be parsed into integers, right? And then you do some arithmetic operations on them, right? And this is an example of hyperlinks that navigate to that page, right? Encoding values of 1, 2, 3, 4, and then they evaluate to 1 plus 2 or 3 plus 4. Now we're going to be using this quite a bit in our assignments when we're implementing Kambaz, because we're going to be encoding the course ID, right, in the path. Right, we're going to be able to retrieve those IDs and then look them up in some data structures so that we can render those courses or those modules and whatnot. Okay. All right. Let's take a look at how we can use some of our skills, right, to revisit the implementation in Kambaz, right? We want to be able to have a lot of the content that we've been developing so far has been pretty static, right? But now we just learned how to use JSON and iteration and map, and so let's see how we can apply them to re-implement some components. For instance, let's take a look at our navigation. Let's start off with a table of content. So our current table of content is pretty static, right? It looks something like this, right? You have a whole bunch of components, nav link, with a whole bunch of hrefs that allow you to navigate to lab 1, lab 2, lab 3, blah blah blah, Kambaz, GitHub, and so each one has its own ID, each one has its own label, right? And so there's definitely a lot of copy and paste here, right? And us as developers, whenever we find ourselves copying and pasting quite a bit, where most everything is the same, right? Only just a few things change, right? The href changes, the label changes, the ID changes, but everything else seems to be always the same, right? And so we're looking for these patterns, right? How can we generalize this, right? Can we create a data structure that captures this, right? So let's first, what we can do is, once we identify these patterns, we can, generalize it by capturing a data structure that encodes the data that changes over time, right? Only what is distinct in each one of those templates, right? And then what we could do is then declare a generic template where we can dynamically create this, right? Use one of these as a template, and then just copy and paste the values and change them over time, as we iterate over the data structure, right? So given this data structure, we can now redefine, right, the implementation of our navigation table of content, as a map. The map can iterate over the link and generate each one of our nav items, right? Where we can, as we're iterating, we can define the href, the IDs, the label from the data structure. Okay. Now, and this is great, right? This definitely makes this dynamic and can be configured. It's much easier to add new links, right? I just add a new object into my array of links, where but the algorithm to generate them doesn't need to change, right? It's smart enough to generate for any new link, right? Now, one word of caution is that the all these nodes are being added dynamically to the DOM, right? And React needs to be able to keep track of all these items that are dynamically being added, right? It needs to maintain a unique identifier for each one of them. And the way it does it is that you have to provide a new attribute called key, which is the equivalent of ID, right? ID is what HTML uses, to uniquely identify, node elements in the HTML and the DOM, right? Key is more for React. React keeps track, of the data structure that is being created in a virtual DOM, right? And so to keep track of its uniqueness, you have to provide a key that is a unique value. So here we're using the ID, which we're guaranteeing to be unique. And so that's the use of that key. Okay. Now, let's try and apply additional things, such as, for instance, highlighting links, right? Like active, using the path name and using parameters and so on, right? So, for instance, if we now take a look at the same data structure that we had earlier, right? We can grab the path name, right, from the hooks, right? That we can then use the path name to determine what links we want to highlight, right? So, for instance, we can say, well, if we can add a class name in there that checks to see if each one of the href ends with the if the path name ends with the href, then, right, we apply the active class and it'll highlight it, right? So that when you click on the on the particular link, right, it'll highlight the pill, right, so that it gives you a visual cue of where are you, right, in the entire application, right. All right, so we can use these same skills, right, to revisit the implementation of all our navigation sidebars, right. The left-hand side has a couple of sidebars. The has a Kambaz navigation and the course navigation. Both of them can be re-implemented using the same strategy, right? Currently, it's implemented something like this, right? We have, a very long list group, in the Kambaz navigation for, Northeastern and the account, dashboard, courses, calendar. And right now they're just copy, paste, copy, paste, copy, paste, right? So we can apply the same strategy as before, where we're looking for patterns, right? What are the things that are changing over time, right? Definitely the href that allows us to navigate to different places, the account, dashboard, right? Here, the course navigates to both the courses and the dashboard navigate to the same thing, dashboard. We have calendar, inbox, labs, and so on, right? Then we have the labels that are displayed, right, for the users to know where we are, what is it that you're clicking on, right? Account, dashboard, courses, calendar, and whatnot. But then we also have some classes that we use for highlighting, right? Here we have the account is being highlighted. We have the background is white, okay? The text is red, but then all the other ones are not highlighted, so the background is black and the text is white, okay? Or red. Maybe because it'll be danger as well. So first, let's implement the highlight. How would you highlight these in each individually? Because notice that the rules is a little bit different, right? Depending on whether you're selected or not, right? With the path name matches and whatnot, you would highlight. Otherwise, you don't highlight. And then we'll create a data structure. Okay. So here we're grabbing the path name, right? And then we are going to apply a different class or a different set of classes depending on whether the path name matches, right, a particular path name, right, or a particular pattern. So if it ends with account, we add we highlight it, doing background white and the text danger. Otherwise, right, we not highlight it, making the text white and the background is black. Right, and notice that it's the same for all of them. See that? So it's when it's highlighted is red on white, red on white, red on white. And when it's not highlighted, it's white on black, white on black, white on black, right? So if it matches, see that? Now, having identified these patterns, okay, we can apply the same strategies as before. We grab the things that only change from one link to the next, right? Where the href is different, right? The labels are different. Now notice that if the href and the labels would have been the same, it could have been this. We could have used just href or label, right, where one could be derived from the other. But here we had to be a little bit different because the courses and dashboard both navigate to dashboard, right? So we couldn't just use the label, right? Unfortunately. Also, the icon is different, right? So we've imported all of them into an array, okay? And then so now we can, collapse, right, all these links that we had. I don't know, we had like 10 of them, into a single, map that we can just iterate over the array, right, and dynamically generate the list group item, right, and then add the rule, the logic on whether we're highlighting or not, right, based on the label, and then we apply either red on white or white on black. Okay, and then we have the icon, right, that is have a reference to that, which gets applied here with the so it's always red, red on whatever background we have. Okay, whether it's highlighted or not, the the color of the icon is always red. How about course navigation? So course navigation, same thing, right? We have the sidebar that highlights. They're all red, red on white, red on white, red on white. Right? The only one that is highlighted, right, is this one is active, where the text is not red. It's by default it's black. and it also adds, the active class also adds this additional border on the left, right? And so we can again find what are the things that are in common, create a data structure. But before we get to that, uh, the we have to make sure that capture, right, the ID of the course, right? Remember, we had hard coded them all to just be 1, 2, 3, 4, right? And so this caused the problem that, even though the dashboard, you might navigate to a different course, and and we would capture the ID in the URL. We would, once you started navigating within a course, we would go back to just 1, 2, 3, 4, right? So we don't want that, right? We want these to be real. We have presumably the CID has been encoded in the URL. We can grab that from the parameters using use params. Use params, we can grab the CID from here, right? From navigating to that particular page, right? And then we can encode the CID in each one of the href. Notice that the href here were hard coded. See that they used to be all double coded here, and then now they become expressions. See that, where we're using the template string, and so that we can dynamically encode the ID in there, so that when you start navigating home, modules, Piazza, you're still in the same course. Okay, very, very important. We can also not only encode the CID, but we can dynamically change the look and feel, right, of the class of each one of the line items, right, by applying active or not applying active, right. And so if you navigate to home or modules, we check to see if the URL ends with that text, right. If it does, we apply the active class. Otherwise, we just change the foreground to be red, right, and border 0. Notice that this one active doesn't have border 0 because it is adding a border on the left side, right, the dark, left sidebar. The border is, and then foreground black, shows that the link is active. But then if it's not active, they're all white background, no border, and the text is red. Okay. Then we start to apply some generalizations where perhaps here too, notice that the label and href are almost identical, except for the people is slightly different, right? And so the label is people, but we're navigating to actually a people table. So if we didn't have that special case, perhaps we could have just used a label to generate everything, right? Or perhaps you can have like an exception where if you get to people, then it's something different. Otherwise, use the same thing. Okay, and then now we can iterate over the links, right? Instead of having 10 or 15 different link elements, we can generalize it to just iterate over the array, right? And then dynamically render the link with the path name, checking to see if it ends with href, right? To apply active or not, right? And then encode the CID, right, in the href. Okay. All right. Yeah. So let's apply the same strategy for the dashboard, right? The dashboard, the same thing, right? We have a data structure, right, that we want to iterate, right? And presumably the data structures have information about the different courses, right? Rocket propulsion, aerodynamics. You have the title, maybe the ID of the course, the description of the course. Now the data structure is I'm giving you a link to the data structure from GitHub. If you click on this hyperlink, you can download the JSON file and you can store it, in a local file. I'm calling these kind of like a database. Not really. This is not a database. This is just a a JSON file, and I'm putting in a folder that I call database. This is in preparation for later on when we actually do have a database, and we're going to connect to it through a server. Right? It's going to have a similar implementation and structure. So this is, quote unquote, a database, not really a database, but it's just a whole bunch of JSON files that we're going to collect into one big object, right, of courses, modules, users, assignments, quizzes, all within one big object that we can then navigate, as a big, using dot notation, right, into one single file called index.tsh, which is combining all these. Right now, just courses, right? Then from the dashboard, instead of having, copy, paste, copy, paste, copy, paste all these courses, instead, what we can do is, grab the courses from the database, right? Print out how many courses there are in parentheses. Here, these used to be hard coded, right? Now it could be dynamic. It's the length of the array of the courses, right? And then, instead of having all these links copy pasted all over the place, right? We can just iterate over the courses, right? We can iterate over the courses, right? And then the course have their own IDs. And, all right, something that we're missing here that should be here is the key. Here, there should be a key that uniquely identifies these, right? That's probably the browser's complaining. And then we encode the ID in the courses, right? To go by default, when you click on each one of the cards, it's going to go to home, but it'll encode the ID of the course here so that we can grab that, right, from any of the pages that are implemented inside of the courses. The home screen, the module screen, all of them, right, are going to be able to grab that ID using use params, right? And then, the title is also the name of the course, the description is there, right? And so instead of these being hard-coded like we have so far, now these guys are going to be dynamic. And so, before we had, like 7 or 12 or I don't know how many courses, just remove all of them and just keep just one of them and then use as a template, right? And replace the hard-coded names and the hard-coded descriptions and whatnot, right? And replace them with the properties in the course object. Okay. Same thing for the same thing. The same kind of strategy can be applied, when you navigate to a course, right? When you navigate to the course page, the course layout, if you remember, rendered the name of the course at the top, right? And we can do that by grabbing the course from the database, right? Grabbing the ID from the params, okay? And then looking up the course, right? Iterating, looking for it, in the array of courses. And once we have the course, we can dynamically then render the name of the course from the object that we find in the data structure, okay? So modules can also be rendered dynamically, right? We can render all the modules for a given course, right, by looking up for the ID in the parameter, right, in the path, and then iterating, looking for the modules that are defined for the particular course, right? So you can download the modules from GitHub, right? Take a look at that. Each module, you're going to add the modules JSON to our index, to our quote unquote database, and then each module, if you look at the implementation, has a reference to the parent course, meaning what course does it belong to, right? So each module has the name of the module, a description of the module, maybe a optional lesson, right? But then it has also kind of like a foreign key that references the course it belongs to, right? So from within the modules, we can grab the params of CID that is encoded in the URL, and then we can use that to look up and filter all the modules that belong to that course, right? Because modules have a field called course, right? And so we can filter and say, well, I don't want to see all the modules. I only want to see the modules for this particular course, right? So we can filter and say, okay, well, given the course, go iterate over all the modules, look up only the modules whose course is the CID that is encoded in the URL, and then this gives you the subset of modules for this course, right? Then we iterate over the surviving modules for that particular course, and then we can use the line items for each one of the courses, right, as a template, and then we can dynamically render the name of the module, the description, and some modules might have an array of lessons, right? If so, notice the ampersand ampersand, meaning if this is defined, right? If this exists, this returns either true or false, right? If it does, then we keep rendering a sub list, right? Another sub list of lessons, right? We're going to iterate over the lessons, and then rendering the name of the lesson, right? If there are any lessons rendered defined for that module. Okay. All right. That's all I had for you today.